Hello students, today's our topic is common emitter amplifier. In today's topic we are considering NPN transistor so that we can give common emitter configuration to our NPN transistor. In case of NPN transistor common emitter configuration, we will take the emitter terminal of NPN transistor in common in input side as well as in output side. And for the proper working of the transistor, we will bias the transistor in normal mode or also known as active mode. In active mode or normal mode, the input is given forward biasing and the output is given reverse biasing. This forward and reverse biasing of the above transistor is given with the help of DC source. And this reverse biasing and forward biasing, they are independent of the input AC polarity. In we have to make the input forward biased and output reverse biased so that the transistor can move in the or act in the normal mode. In case of NPN transistor, this is our emitter terminal, it is of N type. This is our base terminal, which is of P type, and this is our collector terminal, again it is of N type. As the arrow is coming outward the junction, the base current will come towards the junction, and similarly the collector current will move towards the junction. In input side, we have to give two type of signal. One is AC signal, that is a weak signal which will be given to the input side so that by feeding it to the amplifier circuit we will obtain a strong signal at the output side. In the input side we will give AC weak signal plus a DC source so that the emitter base junction can be forward biased. First we will make forward biasing in the input side, that is at emitter and base terminal. This emitter is N-type semiconductor, so we will connect the negative terminal of the battery to the emitter and the positive terminal of the battery to the base region. And as the input side is our base terminal, we are symbolizing our source by VBB, and an input weak signal is given into the input also. This is our input signal which we have to amplify. In the output side we have to take our output signal, and that output signal is our strong AC signal, and this strong AC signal will be obtained along the high resistance which we are indicating here with the help of RL, that is load resistance. Hence, to get the output we will take the load resistance, and across this resistance we will take our output signal, and that output signal is a strong AC signal. To make the output reverse biased, we will connect the N-type semiconductor of the collector to the positive terminal of the battery, and hence the negative terminal of the battery will be connected with the N-type emitter, and this battery is making reverse biasing of the collector region, so we are giving it the symbol VCC. In this loop, if we apply Kirchhoff's loop rule, we will find out that this is our positive terminal, and from this positive terminal, let us consider the current is moving, and in the same direction the collector current is moving, and if we move along this path, the emitter current is also moving in the anti-clockwise direction, and hence the loop is completed. By applying the Kirchhoff's loop rule, we will have the total voltage is divided into two parts. One is the voltage across the load resistance, that is our output voltage, and the voltage across these two terminals, that is the collector and emitter terminal. And let us consider the voltage along these two terminals is indicated by VCE. Hence, there are three voltages. One is reverse biased voltage, one is output voltage across the load resistance, and another is the voltage which will change due to the change in the output current. This is our voltage across the collector and emitter region, and this will decide whether this voltage will be small or not. Hence, VCC is equal to ICRL plus VCE. The three voltages in the loop is given with the help of this equation. Now we have to discuss about the voltage across the two terminals, output terminals, that is collector and emitter terminal. From this equation we will get VCE is equal to VCC minus ICRL. And if you observe this equation, in this equation the reverse biased voltage, it is a constant quantity, and the load resistance in the output circuit is also a constant quantity. It means there in this equation there are only two variables, and this variable will make this variable change. It means this is an independent variable, and this variable, that is collector current, will increase or decrease the voltage across the collector and emitter terminal. This is an important equation by which we will discuss the working of our common emitter amplifier. In common emitter amplifier, we will taking a small signal or a weak signal in the input side, and when this is fitted in the amplifier we will get a strong output signal, and we will find out what will be the phase relation in between the input signal and the strong output signal. Let us consider first in this side our input signal, positive half of the input signal is facing the circuit. If positive half is fitted to the positive, it means the forward biasing is going to increase, and it will increase the input current. If input current IB is increases, indirectly we know that IE is equal to IB plus IC. It means if IB is increasing, it is making IE increased, and if IE increased, we very well know that IC, that is the collector current, is approximately to the emitter current. Hence, in the input current is increasing, that is base current is increasing, then output current also increase in this given circuit. And according to our equation, if IC is increasing in the above equation where RL is constant, VCC is constant, it means this whole factor is going to increase, and if this whole factor is increasing, it will decrease the voltage across the collector and emitter region. It means when there is an increase in the collector current, there is a decrease in the collector emitter terminal voltage will going to decrease. Decrease means that is less positive, or you can say that more negative. It means for a positive half of the input signal we are getting a less positive or more negative signal in the output side. Similarly, if we discuss, sorry, when the negative half will given to the base terminal, then it will make this p-type semiconductor more less forward biased. If IB is small indirectly by with the help of this equation, if ib is small it will decrease ie, and if ie is small it will decrease ic. It means due to the negative signal, this p-type semiconductor is less forward biased, and which will decrease the input current, and this decrease in the input current will decrease the output current. Hence, in the second case, we are considering that or finding out that the IC is decreasing. And if we put this condition in this equation that IC is decreasing, where RL is constant, VC is constant, it means this quantity is small. If this quantity is small, it means this quantity will become large. Now, VC will increase. If VC will increase, it means it is more positive. More positive means we will have a strong output signal. Now, if we consider input and output signal, we are finding out that for positive half we are getting negative half, and for negative half we are getting positive half. It means in between input and output signal there is a phase difference of 180 degree. For crust we are getting trough, for positive half we are getting negative half, and for trough we are getting crust. It means for negative half we are getting positive half. It means the signal is not linear. To make the signal same as the input, for positive we want a positive output, and for negative half we are want to a negative half, we can take two-stage common emitter amplifier. In two-stage common emitter amplifier, we will connect one amplifier output to the second amplifier input. In this case, if this is our common emitter amplifier and this is the first stage which we have represented in this circuit, this is our first stage, and for this first stage we find out that for this type of weak input signal we are having a output signal, strong output signal. This output signal is the output of our first stage amplifier. If this output is given to the second common emitter amplifier, it means it will behave like an input signal. For the second stage amplifier we will have a positive half. For this negative half we will get a positive for negative, and we will get a positive for negative. It means this is our final output signal and this is our input signal. And now you are observing that for positive half you are getting positive half, and for negative half you are getting negative half. So to overcome this limitation that the input and output has a phase difference of 180 degree, we can use double stage or two stage common emitter amplifier, in which the first stage phase difference and second phase difference, total phase difference will become 360 degree, or you can say that it is 0 degree. We can withdraw this limitation with the help of common emitter amplifier. This is the working of our amplifier. Now, in this amplifier, our output current is collector current and our input current is our base current. So, the ratio of the output current, that is our collector current, to the input current, that is our base current. Here this is known as current gain, and current gain in case of common emitter amplifier is indicated with the help of beta. You know very well the collector current is in the order of of the order of milliamperes, and base current is the order of microamperes. And by calculating all these orders, you will find out that the current gain is approximately 1000 times of our input current. It means if we are giving 1 ampere of current in the input side, we will get approximately 1000 amperes of the current at the output side. Due to the increase in the current, we will have a voltage drop, that is ICRL, across the load resistance, that is output voltage. If IC is large, approximate 1000 times to the input current, we will find out the output voltage is very large. Hence, common emitter amplifier has many advantages. They have large current gain, that is beta, and they have large voltage gain also. And if they have large current gain and voltage gain, and we know that power, it is a multiplication of voltage and current, we will have a large power gain also. Hence, common emitter amplifier is preferred over common base amplifier.